Hi, my name is Gabriel. I've been studying some resilience pattern the last couple of weeks, especially the Bulkhead pattern, and I built an application that reproduce the problem that the pattern intends to solve, and also the application show how the problem is solved through the use of this pattern. I'm going to show you the application, but first of all, I would like to mention something that I found interesting. What really helped me to understand the pattern was an article from this book where the author mentioned the idea of isolation levels. So when we apply a library like Resilient for Java that implement the pattern, we are just building some conceptually boundaries around our CPU. This allow us to avoid that the whole application fail when a component starts to consume all the available threads. But what happens if, due to an error, our one component of our application starts to consume all the memory, all the RAM memory? In that case, the previous solution is not going to help us. Due to a memory leak, the whole application will fail. So we need to, if we want to avoid that, we need to build another kind of bulkhead. For example, we need to run our components in different processes. We need isolate our component in different processes. For example, using some kind of container. And following the same reasoning, what happens is the underlying operating system fail. Again, the whole application will fail. So we need to replicate the operating system and, for example, to run our application components in different virtual machines. And the same idea applies for hardware. If we run our application in the same hardware and the hardware fail, the whole application will fail. So we need to replicate our components in different hardware and use some kind of load balancer, for example. This helped me because what I'm doing in this application, or in general when we use implementation, the Bulkhead pattern at software level, is just to try to avoid one particular problem, that a component consumes all the available threads. But the Bulkhead pattern ideas are more wider than just try to solve this problem. So this is the application. It's the ship. It's the ship that we are going to try to sync. It's just an example. It has two clients, client A and client B. Client A has a dependency with service 1 and a transitive dependency with service 2. And client B has a dependency with service 3 and a transitive dependency with service 4. And also we have a client C that is the hole in our hull. We are going to put some water in our ship through this client. It just adds some delay in the execution method of service 2 that simulates some problem. The details. I use JMeter for the clients, Spring Boot to build applications, Tomcat as a servlet, Resilience for Java is a library that implements the Bulkhead pattern, Micrometer to register some database, some metrics on a timeline database, and Grafana to visualize the information. So this is our first scenario. We are going to reproduce the problem. We are going to propose a cascading failure due to resources exhaustion. Why? Because when we call from service 1, we call service 2, we are not using any kind of protection. We are not using any kind of resilience pattern. So service 2 will start to fail, and obviously client A will be affected. However, after a while, client B will be also affected, and we don't want that because client B has not a dependency with service 2. However, the whole application is going to fail, so client B will be also affected, and that is the problem that we want to solve with a Bulkhead. So I started the server. Now let's see the client. Here I have two requests generator, client A that sends request to service 1, and client B that sends request to service 3. And using this plugin that allows me to generate a constant number of requests per second, in this case 7 requests per second per client after a ramp-up period of 16 seconds. Let's start to generate some requests, and let's see the transaction per second graph. Okay, the number of transactions will keep growing for a while. Let's see the server side. Here I have 4 graphs on the right side that show the response time of each service. I put a delay on each service that simulates some work. I'm not sure about what are these peak values, but anyway. On the left side of the screen, this graph shows the transaction per second that service 1 is processing, and the incoming transaction per second that service 3 is processing. We are about to finalize the ramp-up period, so now we are processing a total of 14 transactions per second. And here is the server status. We are monitoring the number of busy threads and the number of connections that the service is using. I changed it. Let me show you the configuration of the server. I set 10 as a maximum of thread and 10 as a maximum of connection. I know that these are very unrealistic values, but the idea is to simulate or to generate or to create a resource exhaustion situation. So let's check the client again. Here we are now generating 14 transactions per second. 7 for the client A and 7 for the client B. Also the response times are very consistent, I think. We can say that our application is running well. So now let's try to put some water in our ship. Let's try to simulate an error in service 2. With this endpoint, we're going to set a delay of 500 milliseconds. So let's see what happened. Let's check the server side. Now, service 2 take 500 milliseconds to process each request. Also, service 1 take that time because service 1 depends on service 2. But service 3 and service 4 remain the same. And the number of transactions that we are processing, it seems that has kept the same, 14 transactions per second. But the problem is the server. As you can see, the number of busy threads has reached a maximum of 8 at some point, and now the service using say six thread, and the number of connection vary from 9 to 10. I think that now the server is quite busy, but still is able to process all the incoming requests, I think. Let's check the client side for a moment. The response time was client A, as expected, has reached the 500 millisecond per second, 500 millisecond per request. But so obviously we have a problem in client A, but client B is still working well. Let's check the transaction per second. And the whole application is still processing 14 transactions per second. So clearly we have a problem in a service that impact in one of our clients, in this case in client A. Okay, now let's put more water on our ship and let's try to sink it. Now, okay, service 2 and service 1 are affected by the problem on service 2, but the important thing here is that our server is going to collapse, I think. Now is using the maximum of available thread and the maximum of connections, and you can see on the left side that the service is not able to process a constant number of transactions. Now, in fact, the last second is process only 3 transactions per second on service 3. And here we can say that the whole application is not working well. Let's see the client side for a moment. Now we can see that the response time of client B vary a lot, and clearly we have a problem in client B. Let's check the transaction per second. Now the application in general is not able to process a constant number of transactions. And the transaction per second on client A has decreased, and the transaction per second on client B also has decreased. So now the problem on service 2 has originated that the whole application feel the impact of that problem. And I think this is the situation that we want to avoid when use a bulkhead pattern. Now let's see the solution of the problem. Here we will use Resilient for Java, that is a library that implements the bulkhead pattern. So every time service 1 calls service 2, it will use this library. And so we are building some CPU partitions in our application that will protect us from a failure on service 2. Let's start the client again, and let's wait for the ramp-up period to finalize. In the meanwhile, we can see some code. Here, this annotation provided for the library is the implementation of the pattern, and every time the Bulkhead rejects a request, it will call this method that will register a metric on the database. We'll see that metrics in this graph. And let me show you the Bulkhead configuration. It will allow a maximum of 2 concurrent calls, and if the request is not processed after 10 milliseconds, it will be rejected. Let's check the server. We are about to finalize the ramp-up period. Okay, this is the same scenario as we saw before. So let's put some water in our ship. Let's start with 500 milliseconds. Let's see what happened. Now we can see that the Bulkhead is rejected some transaction. In this case, 6 out of 10 transactions were rejected. 4 out of 8 transactions were rejected. I'm not sure why sometimes the number of rejected transactions is greater than the incoming transaction, but remember that the Bulkhead add a delay in the middle, so maybe that is the reason. So 4 out of 8 transactions were rejected, and so on. At this point the server is a little bit more busy, but it's a very healthy server, I think. Let's check the client side. We can see that now we can see that we have a failure transaction, and also we have success transaction. Maybe this graph show the values better. And these are the transactions of client B. Client B has not been affected to the problem, but we already know that with a delay of 500 milliseconds, client B has not impact. So let's put 1 minute delay on service 2 and let's see what happens. For me, the more important thing is that our Tomcat status remain the same. In the previous test, when we set a delay of 1 second in service 2, the Tomcat crashed. So this is the first, a very important advantage of the pattern. Our server is working very well. Of course, we have a lot of rejected transactions, but we also can observe that the number of transactions per second processed by service 3 remain the same, remain at a constant level, 7 transactions per second. So let's see the client perspective. Okay, client B is working very well. It's processing 7 transactions per second, and the response time is very constant. We know that these peak values probably are due to the computer CPU high work, but we can say that client B is not affected by the problem in service 2. Let's see the transaction per second on client A. Now, after the delay of 1 minute, the majority of transactions fail, but still the service is able to process a number of success transactions. So we can see that we had a problem in service 2 that affect client A, but our application is still running. Let's see the transaction per second. We are still processing 14 transactions per second, and client B is working well. So I think this is the the impact that the Bulkhead pattern has on our application. We prevent that the whole application fail due to a failure on service 2. Okay, that's all. Thanks and see you.